Hello and welcome to our final project video for our machine learning project, Predicting Unicorn Startups. Today we're going to walk you through our methods and some results that we got. So just beginning with an overview of our project. We wanted to use machine learning to look at early level companies and try and predict whether they would reach unicorn status. We employed a variety of classification algorithms and also did some feature engineering as well as looking at sector level data. And ultimately, we were able to run quite a few experiments on this question. So our data actually came from a PitchBook inventory of deals. So each row corresponded to a deal and contained information about the business, the deal, industry level features, as well as investments. And so for our model, we wanted to be able to input it at a business level. And so ultimately, we ended up transforming the data to have one business per row. And in our first data set, there were at least 2 early rounds of data, either the seed round or early stage series A, and then at least 3 rounds total. And then in the second data set, which was much larger but had fewer features, these businesses had at least 1 round of seed or early stage series A deals and at least 2 deals total.
And before we could run any of these models on the data, we had to find a way of representing our categorical features numerically. And so to that end, we tried 2 different ways of transforming these categorical features. One of them was using an embedding encoder. And this kind of spoke to our hypothesis that there might be some sort of relationship, especially between sector level categorical features that could somehow help the model learn which companies were going to be successful. So the embedding encoder takes the categorical variables and then it creates these numeric vector representations using a perceptron, multi-layer perceptron. And this is supposed to kind of encode that relationship between the variables, which we hypothesized would help the model better predict. And then as kind of a control to that, we also tried encoding with one-hot labels, which is obviously just a binary feature for each of the categorical values, but does not kind of encode that relationship. And so with these 2 data sets and these different ways of encoding, we ended up running 3 different classification algorithms on this data. And one thing that we realized very early on is that there is an extreme minority class, obviously the unicorns. It represented just such a small fraction of our data that we ended up having to upsample this class in order to, not just predict negatives across the board. And so with this upsampling and then the not upsampling experiment as well, we ended up running 24 experiments in total across all these algorithms, techniques, etc.
We also generated confusion matrices for the results, where the vertical axis is the true label and the horizontal axis is the predicted label. And we can see here from the original data set without upsampling, there's very high true negatives, and the other boxes are pretty much trivial, which aligns with the F1 scores of 0 that we observed. And then with upsampling, there is a increased number of true positives and an overall larger proportion of false positives as well.
So in thinking about these results, we were honestly a bit surprised about the extent to which this kind of extreme minority class affected our data. Obviously, the biggest obstacle that we ended up encountering was just these consistent negative predictions, regardless kind of all of the other things that we altered. And so despite even with upsampling, we really struggled to kind of see any meaningful results with our other experiments just because of this one obstacle. Though, of course, we did notice that upsampling improved the performance of our model, as well as using dataset 1, which included an extra round of funding, which probably should come as no surprise.
Yeah, and then looking forward at ways to improve this model, we're definitely focusing on better methods of upsampling and improving the predictive quality of the minority class. And so one idea would be, rather than using a random upsampling technique, using generative algorithms to really create some rows that better exemplify the sector level features and can help parameterize the model in a way that accounts for the minority class better.
We also had another idea for increasing and creating a more varied representation of our minority class, and that is changing the criteria for what qualifies as a unicorn in our training set. Currently, we are defining unicorns as companies that have a valuation over 1 billion. But for example, we could look at companies with a valuation of greater than 800 million. which would broaden the minority class, and then train on that data set, which would capture similar features to just successful startups in general, similar to the unicorn, the original 1 billion unicorn class. And we would then evaluate that model on the test set with the normal $1 billion valuation criteria.
And so kind of just in conclusion, in going through all these experiments, we realized that similar to what we learned in the best practices lecture, the data really is the most important thing. And no amount of feature engineering using different models, et cetera, can make up for what is ultimately just a very difficult data set, a heavily imbalanced data set. And so if we were to continue with this project, which we would potentially be interested in, we would really just like to kind of do a deep dive on the data and think about how we can really engineer it and represent it in a way that best kind of encodes the problem that we're trying to solve, because that was ultimately the biggest problem we ran into, but also what would potentially fix the problem. So thank you so much for listening.